The next video in our triangle unit is going to build off the congruent triangles from the last video. So if you haven't watched that one, please go back and watch it. And this one you get to follow along on a PowerPoint, so if you don't have the PowerPoint presentation notes, again, I wouldn't write much down without that. You can still listen. So this is on proving that triangles are congruent. So in the past, what we learned is the idea of congruence means that two geometrical figures with exactly the same shape and the same size. So these two are considered congruent because they are the same shape and the same size. Okay, we already learned that. So we also learned in the last lesson that there are 6 pairs of corresponding parts, that there's 3 sides. So right here, these are the sides. Okay, so AB, I'm going to mark these. AB is congruent to DE. BC is congruent to EF, so I'm going to fill that in right here, EF. AC is congruent to DF. Okay, and then we have 3 pairs of angles, which A is congruent to D. Fill that in. B is congruent to E. And C is congruent to F. Alright, now I know we've probably said to ourselves, this is a force. 6 times to mark kind of gets ridiculous. Well, guess what? How much do you really need to know about 2 triangles to show that they're congruent? Okay, do you really need to mark all 6 parts? This is what we're going to learn about today. No, you do not need to mark all 6 parts. Okay, there are 4 different ways, and they're right here at the bottom. There are 4 ways to prove triangles congruent. And these are the abbreviations. Okay, SSS stands for side, side, side. SAS stands for side, angle, side. ASA, angle, side, angle. And AAS, angle, angle, side. So we're going to go through what that means right now. So the first one is called side, side, side. So you can state that 2 triangles are congruent right here if all they have are their sides marked. So you don't have to worry about the angles. If they state that all 3 sides are equal and it looks like this picture, then you can go ahead and say, yes, these are congruent by side, side, side. So you would say triangle ABC is congruent to triangle DEF by SSS. So you don't have to go through and list all the parts and mark all the parts. SSS works. That's the first one. Okay, the second one is called side angle side. And side angle side means that you would have a side, 2 sides marked, and an angle in between them. So, sorry the triangle's kind of screwed up on the right here, but if we look, AB is marked with 1 slash and DE with 1 slash, so that's your side. Okay, then you have angle A is marked with 1 swoop and D is marked with 1 swoop. So that's your angle. And then you have AC is marked with 2 and DF is marked with 2, and that's your other side. So we can say here that triangle ABC is congruent to triangle DEF, but this time the reason they're congruent is because of side angle side. That just the side angle side is marked. Okay, the angle here is called the included angle. And it's called the included angle because it's between the 2 sides. That should make sense. Okay, so we're going to take a look again at what included means because this can be tricky. So next we have, again, the included angle is the angle between 2 sides. So in the first example on the on the left here, what angle is between the 2 sides marked in the blue? Hopefully you recognize that it's G. So angle G is our included angle. In the middle here, which angle is our included angle? I. In the last example, which angle is the included angle here? So which angle is in between the 3 blue stripes here and the 2 ones here? H. So that's how you pick out the included angle. Just so you understand, included angle, SAS, all of these are marked as SAS because the angle is in between the two sides. Okay, so you got two so far. You got SSS and we have SAS. Okay, the next one is called angle side angle, or ASA. Okay, we're going to fill in and mark DEF over here. So we have AD, the first statement, AD is congruent, A is congruent to D. So A has one swoop, D will have one swoop. AB is congruent to DE. We have one slash there. And angle B is congruent to angle E, and that's two swoops. So in this triangle, we could say that ABC is congruent to triangle DEF, and the reason is because by angle side angle, because again you have an angle marked, a side marked, and an angle marked. So it's ASA. And this time, instead of having an included side, you have an included angle. And that's the angle in between the two sides. Okay, so again, to practice that, to make sure that we get it, the included side between two angles. So here, IG is your angle, and your side would then be IG. That's your included side. Okay, our angle here is I and H. What is the side that's in between those two? IH. That would be your included side. And the last one, our two angles are G and H. So our mark would be GH. That would be the included side. Alright, so just to recap, we have SSS so far, we have SAS, and we have ASA. Alright, next. Angle, angle, side. This is the last one. Alright, so this time, angle A is equal to angle D. So we're going to swoop that once. And this side, angle B is equal to angle E. So we're going to swoop that twice. And lastly, BC is equal to EF with one slash. So do you see the difference here? The non-included side is EF. It's not in between the two angles. So this would be AAS. So triangle ABC is congruent to DEF by AAS. Alright. Now there are two combinations of letters that we haven't used yet. One of them is SSA, or if you reverse that, what would that spell? So that's one way for you to remember that ASS is not possible. It's not true. So if you see anything marked like these down here with ASS or SSA, this is going to be not possible. Okay, the other combination that we don't have is no AAA. It's not possible to have just angles marked in it to be congruent. And I'll show you and explain that later. So AAA, this would also be not possible. Alright, so let's review this again. We got SSS, ASA, SAS, AAS, SSA does not work, and AAA does not work. So these four are the only four possible to show that triangles are congruent, only marking 3 things instead of all 6. So these are shortcuts. So let's take a look at what this could possibly be. So I'm going to help you out here and we'll try to figure out what the answer is. So you have 4 choices. Again, you have AAS, you have SAS, you have SSS, and you have ASA. So the first one, let's take a look at this one. So here we have marked a side, an angle, and a side. Same thing here, side, angle, side. So these two are congruent by SAS, side, angle, side. Okay, example 2 here, let's see what we got marked. We have an angle, a side, and an angle. Same thing down here, angle, side, angle. So these are congruent by ASA. Okay, now the one on the bottom left here, let's look at this one. So we have an S, an S, and an A. SSA. So is this SAS or is it SSA? It's SSA because up here at this example, see how you have the included angle is right between the two legs? This angle is not between the two legs. If it were between the two legs, this would be marked over here. So this is an ASS or a not possible. You cannot prove that these two are equal. You need more marks. And the last one on the right, this is SSS. So side, side, side. So that's all you're doing is you're looking at pictures and you're determining how are these marks, what are the letter combinations, are they equal or not. Alright, let's try one more. Alright, this one right here on the left, these are angle, angle, angle. They're all angles. Not possible. Okay, the one here on the right, okay, we have an angle marked, a side, and an angle. Angle, side, angle. So this one would be congruent by angle, side, angle. Okay, over here on the left, I got side, angle, side, and this one has the same markings in the same order, so this would be congruent by SAS. And the last picture on the right here, we have a side, side, angle, side, side, angle. So hopefully you're noticing, hey, this angle is not the included angle. If it were, it would be in this position right here. Then it would be SAS. Since it's not, this is SSA, which equals not possible. Okay, these are some special cases. Now let's look at this first one, last one. Alright, this, if you notice, are two different triangles right here. Okay, you got one triangle over here in the green, and then you have a second triangle over here in the orange. So even though it looks like one big triangle, it's actually two. So what we got here is we have a side and an angle marked in each picture. There's only two pieces marked. We need three. Well, they share this side in common. It's the exact same side whether you're using it in triangle 1 or in triangle 2. So that means that this is actually the same side. So we're going to go ahead and mark that. This is called reflexive. Reflexive means that you're sharing the side. So actually this is going to be congruent by SAS. SAS because they share that side. Okay, the one on the right here, so again we have two different triangles. You have this one in the pink, triangle number 1, and you have this bottom one in the green, triangle number 2. And if you notice, they also only have two sides marked right here between each. So is there anything else that they have in common? Hopefully there's a bell going off and you're like, ding, 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 ding. I have vertical angles. Wham, bam. So look, guys, all of a sudden we have an angle in here, and now these are congruent by SAS. Alright, so let's look at the last two, which are very similar to these. So if we look at this picture right here, hopefully you're noticing that it's the same as this one, and we can swoop these verticals, and now you have an SAS. And lastly, again, hopefully you're noticing that this one is the same as this one, and we have an angle, side, side. So look what we got in ASS. This is not possible because of reflexive, and ASS is not possible. Alright, now this was long. We'll come and practice next time, and if you need to watch it again, please do.